Thank you for the grand welcome. This is not my first talk, but still it feels like I'm giving for the first time. This awkward feeling is undescribable. But let's get started. So let's tame Git osaurus. I just wanted to give it the Git workflow we deal with every day as Git osaurus because it's just crazy. So why a talk on Git? I'm pretty sure like many of you want to know why, because we have a lot of resources online and we have a lot of talks, but I have certain incidents which I wanted to share. I have seen a lot of developers and some of the students I have mentored in the past. They have a set of 3 to 4 Git commands written on a text file, and that they just use them so that they can create a pull request. Something which goes beyond those commands, that's it. They try to delete their entire clone, fork, whatever it is, and redo everything. And we have to admit it, we must have started off like that. And not only that, one of my friends said that I just asked, like, can you explain me what Git is? The first time when I was trying to learn about Git, Git is a magical tool, and there's something magic happening. Yes, it's a magical tool, but it's what's happening behind the scenes is not really magic. We can understand what's happening there. So with that, let's get started. Okay. Useless. So small introduction about myself. I'm a software engineer at Salesforce. A disclaimer, I'm not a front-end developer, written at the end. And I'm a release lead for documentation in Kubernetes. If you have any complaints about the docs related to Kubernetes, come to me. And I'm an ardent open source contributor. If you want to know how to get started with any open source project, I'm there. And that's my Twitter handle. If you want to just say hello, my DMs are open. That's about me. So some quick things to understand about Git. So I don't want to give a definition, but some things which I feel like we need to know about Git. So yes, we know it's a version control system. But first, Git, what it does, it simply tracks your content. It's a simple content tracker. It tracks all the files and folders you have in your repository. That's it. And just remember that. And the second part is the .git folder. It's a magical folder because it's hidden, but you can still find it. So it is the heart and soul of your Git repository. So when you initialize a Git repository, either by cloning an existing one or initiating an empty repository, the first thing Git does is create this .git folder. And this is the folder that stores all the data, history, everything related to your repository. And when I say that, when you clone someone else's repository, so what exactly is happening there is it just copies all the contents which are inside that Git folder. That's it. And try to open the Git folder which you have in your any of the repository and just explore what's happening there. Going further, we'll be talking about some of the important files we need to know. And the third important point which I wanted to make sure is Git is a tool which wants to make your distributed development workflow life simpler. Like every repository in your workflow is important, and it have the capability to replace the other one at any given point of time. So no repository is central over here. With that, I want to discuss some of the important terminology. We kind of come across these different terms whenever we get to see some Git errors or whenever we read some Git documentation. Often get confused with some of these, so I just want to clarify or give a clear definition. Remote repository, local repository, index, working tree, stash. So I will explain these 5 terms together with this diagram. It actually defines your Git workflow. So let's start with the first one, remote repository. People also say it's an upstream repository or an origin. So in most of the cases, your remote repository is to which all your team members push changes or fetch changes from. And such a remote repository actually exists on some code hosting sites like GitHub, GitLab, or whatever. If you have an internal server for hosting, yes, it exists. And that is known as remote repository. Now coming to the second term, local repository. Um, Git local repository is the one which we make all the local changes to. It is, in simple terms, it's nothing but your .git folder in your computer. That's it. And the third important term, index. Git index is used as a staging area. We might have heard the term staged area, right? So that's nothing but the index area. It actually sits between your working tree and the local repository. So the significance of this particular area is whatever file you add into your staging area, whenever you commit the file, or whenever you want to make a commit, it will pick the files which are there in the index area. It won't pick the files which are in your working tree or your local repository. No, it will just touch the files which are sitting in your index area. And it plays a very significant role. For example, when you run Git Status, you usually see files in your staging area in green text. That means you can only commit the file which is in green text. And also, Git Status is a very helpful command. When you actually sit and read what's going on there, it will give you all the details. It will give you instructions on how you can stage your file, unstage your file, or check out. It's a very helpful command. And also, when you expand the .git folder and look out for the index file, it exists there. Whenever you add a new file, Git will be making some changes to that index file. And if you want to open this particular file and see what's getting added there, it's actually some weird code. I will not be understanding, but yes, there'll be something in that particular file. Now coming to the fourth term, working tree. Okay, so this is also a very important term. It consists of what your current working snapshot. When I say that, if you have two different branches, if you have a feature branch and you're working on that, your working tree will just contain the files which are there in that particular feature branch. It won't contain the files which are in master branch unless you switch. So this context switching is taken care of the working tree area. Now coming to the fifth, the most ignored area or term, stash. The only duty of stash is to keep your working tree area a little clean. So there are certain situations where you try to switch a branch or make some changes. When you have certain uncommitted files in your working tree, it won't let you do that. And in that scenario, you can actually save those files into your stash area and then reapply them whenever you want them in your working tree. And it's actually a very helpful area. It comes in handy. Okay, now comes another important term, head. The question now is, when you run git branch, some branch name, how does Git know the SHA of the last commit? It's because of the contents in this file. Head is a reference to the last commit in the currently checked out branch. And other useful inferences you can get from this particular head pointer is it determines your current working branch. So normally when you check out to a proper branch name, Git automatically moves the head pointer along whenever you create a new commit in that branch. So we will actually see the significance of this pointer when we learn about branching. And if you want to know more about this particular pointer, you can simply run Git Log. And okay. Okay, fine, it's okay. So that's the commit hash, and beside you always see some terms. So what you can infer from this is that head is actually pointing to your master branch, and your current branch is master. And there are also other terms like origin master and origin head. They are the pointers which are in your upstream repository. And that's where your upstream repository is there. So if I actually show you a visualization of this, the box above is upstream repository. If you assume that, its name is origin. And those are the pointers they're pointing to the commit C3. And the box below is what is there in your local repository. So it always carries those remote pointers so that it will let you know whenever your local repository is not up to date with the option repository. And that's how Git knows that. And also when you expand and see what's there in the head file, it actually exists inside the .git folder. It actually tells Git what is the parent for your next commit. And that's how it tracks the branching and all the magical stuff. But don't worry, I'll be clearly explaining with examples going further. Anatomy of Git osaurus. So some of the important internals of Git which we need to know. It's nothing but the contents which are inside the .git folder. We have already seen what head file is, index file is. There are some other important folders and files which I want to discuss. .git/config. How many of you are familiar with this? Okay, a lot of them. So this is the first internal file which I would like to talk about, because this is where all your Git configurations related to your Git goes in over here. You can define what is your option repository is, what your origin repository is, do some branch configuration, push configurations, everything goes in there. This is the central configuration file. And this is quite important. It actually sits inside the .git folder. And now coming to the next important folder, that is .git/refs. So what exactly is a ref? A ref is an indirect way of referring to a commit. And you can think of it as a user-friendly alias for a commit hash. We need not really remember Git doesn't really have to remember the entire 40-character hash. So it simply keeps a track of the files under this folder. And refs are stored in a normal text files in the .git/refs directory. For example, if you open the head directory inside the refs, you will have the list of files which are nothing but your local branches. So suppose I have master branch in my local repository, I will be seeing over there. And if I actually open what's inside the master folder, there'll be another file which contains the latest commit in my master branch. And that's how it keeps track of branching. Even this particular folder plays a role in branching. Now comes to the .git/objects folder. This is the meat of the entire .git or your Git repository. I say that because it contains all the files and folders which are present in your local repository. And the files are actually stored by the SHA values over here. You can see those weird characters. So the way Git arranges them is like in folder structure, so you need not really worry about that. And so I would like to discuss more about Git objects because all your data actually goes into it. So first thing, it's the meat of your local repository. So that means it contains the actual data of your Git repository. And the second thing is, how does Git track or store all your files and folders? In the form of objects, and in the form of those 4 different types of objects: blob, tree, commit, and tag. So I will be talking about the first three object types. And yes, they are stored by the SHA values, as you have seen before. Okay, let's take an example that we have this particular repository and folder structure in your local repository. So we have a root folder. We have 2 text files, readme and makefile, and a /src folder and a .c folder, a file inside the src folder. So let's see how Git actually stores them in the form of objects. So coming to the first basic object type, Git stores your file contents as blobs. So it is important to note that it just stores the contents of your files, but not the file name. So the names and modes of the files are not stored within the blob. I'm just trying to repeat it again. And Git will only store a blob only once. So when I say that, what it means is if you have 2 different file names, but with same file content, Git will be storing that particular file as one single blob because the file contents are same. And what it also means is whenever you try to transfer some of the blobs from your repository to the other repository, if it's the same blob but coming from two different file names, it will just transfer that single blob and then it will expand it into a different files. And for our example repository, those files are being stored as blob with different SHA codes. Now coming to the next type of Git object tree, it solves the problem of storing the file name, and it also allows you to store the group of files together, that is the directory or folder. And a tree is nothing but a simple list of trees and blobs combined together along with the names and the file modes of those blobs and trees. And when you actually go and expand one of the tree object, you get to see something like this. If you it actually contains entries of the blob under that particular tree, the file mode, SHA code, and the file name. And just try to experiment with some of the tree objects. You will definitely get an idea about it. And for the same example, if you see, every folder is actually stored as a tree with whatever file it have within it. Okay, now coming to the third object type, commit. So we are storing the files and folders. Where exactly does the history part comes in? This is where commit objects come in handy. So the commit object is very simple. It's much like a tree. It simply points to a tree and keeps a track of the author, the commit message, and some timestamp around it. Along with that, any parent commit it's pointing to. So if you actually open a commit object, you will get to see the snapshot of that particular commit. Suppose if it's a tree and the hash along with that, and if there is any parent commit, it's pointing to the hash of that particular previous commit along with the author, committer information, and the commit message. So you will actually see all these things when you try to open up these objects and see. All right, done with the boring stuff. We have understood how file stores your data and some of the important terms. Let's discuss about some of the scenarios and concepts with which we struggle every day. First thing is branching. As developers, we all know how important branching is in order to maintain a cleaner workflow. And if you're open source maintainer for any big project, you'll definitely know the pain of merging branches. And sometimes, it's very important to know how exactly Git does this branching. It will definitely make your life a little easier. So let's understand how branching is done in Git. Okay, let's say we have these 3 commits on your master branch, where my head is pointing to the latest commit, C3. Let's examine the state of a branch. So how can I do that? I'll simply run Git Log so that I can see what is exactly happening in my working tree. So what I do, I run Git Log and I get to see the list of 3 commits and some important details beside the latest commit, the top one. This is the JSConf Budapest official website repo. I have cloned it and it's exposing some email IDs. And so what exactly you can infer from this? It says that the head is pointing to the master branch, and you can also see your upstream pointers along with the latest commit hash, as we have already seen. Now, what do I want to do next? I want to create a new branch called React to Meetup. So that's the only branch name I got to my mind when I was preparing the slides, a sensible name, so I just used it. So we can do so by running the command, as you can see, git branch and the branch name. Now, if you want to see the list of branches you have in your local repository and also some important details on what is your current branch, you can run git branch, and then it will clearly tell you that, hey, you're on master branch. I'm making it in green. Okay, now I have created a new branch. What has happened? My head pointer is still pointing to the master, but because I haven't switched to the newly created branch yet. So let's just see what Git Log talks about this workflow. So when I run Git Log, it still shows that the latest commit is pointing to master. We still have our origin or upstream repository pointers pointing to the latest commit, and we have the reactive meetup, the newly created branch, still pointing to the latest commit. Okay, now let's switch to the newly created branch. How can I do that? I'll just run git checkout the branch name which I have already created, and you can verify it by running git branch. Okay, now I am on reactive meetup branch. So what has happened? The head has moved to the newly created branch. So it's pointing now to the reactive meetup. Now your working tree will be whatever changes you make from now on will be going into your reactive meetup branch. Now, if I run git log for this particular workflow, what exactly it shows? You can see the difference, right? So the head is actually pointing to the reactive meetup, the newly created branch, and my master is still having this latest commit in its workflow, and my upstream pointers are still on the latest commit, the last commit. Okay, awesome. Now we are able to create branch. We have understood how Git actually moves the pointers, the significance of the head pointer when it comes to branching. Okay, let's do something more to it. Let's add some more commit to the reactive meetup branch. So I have added some commits, and this is how my workflow would look like now. So I have added C4 and C5 commits to my reactive meetup branch, and my head is still pointing to reactive meetup branch. Everything is awesome. Now I'll run git log. What it actually tells, it tells that my head have actually moved little forward. It actually diverged. It's pointing to the reactive meetup branch. The top commit is nothing but the C5, which I have shown you in the previous diagram. And if you go 2 commits below, you will see the master branch. It's somewhere behind, right? So now we can read git log clearly. All right. Now let's switch back to master branch and see what else we can do. So I have switched back. I run git checkout master, and I'm back on master branch. I have verified it by running git branch command. So what exactly that command did, the checkout master? It actually did 2 things. It moved the head pointer back to the master branch, and it reverted the files in your local in your working directory back to the snapshot the master is pointing to. So this also means that the changes you make from this point forward will get diverged from your reactive meetup branch. Okay, let's see what git log tells now. So I run git log in this current situation. Hey, it's back. Now I won't be seeing those top 2 newly added commits on reactive meetup because I have switched completely to master, and my head is clearly pointing to the master branch. Awesome. Now I'll go ahead and add some commits on master branch. You can clearly see it has diverged from the reactive meetup branch, and the head pointer is, yes, it moved to my newly added commit. Okay, awesome so far. Now where exactly is my origin/master, the upstream repository markers? It's still behind because that's where it is in the upstream repository, and the newly added changes are in my local repository. So if you actually run git log for this scenario, you will clearly see, it will clearly tell you that, hey, head is pointing to master, and the top one is a newly added commit, and my upstream markers are somewhere behind the latest commit. So awesome, everything is like going great. Now let's come back to our current working state of our working directory. Now if I just want to change the commit C6. I mean, I just want to move the commit C6 into my React to meetup branch. I don't want to merge them or do anything else. I just want that single commit into my React to meetup. Something like this. Like I just want to move it into my React to meetup branch. Here comes the concept, cherry picking. Who doesn't love cherry picking? Yeah, in Git it's more fun. So what exactly is cherry picking? It's the act of picking a commit from a branch and applying it to another branch. That's it. And Git cherry pick can be very useful for undoing changes. So these are the steps. How exactly you can do it? Copy the commit ID, the commit hash, switch to the branch to which you want to apply the commit. So in my case, I want to switch to the React to meetup branch, and I'll run cherry pick. So here I do. I check out to the React to meetup branch. That's where I want to add the commit to. And then I will do the cherry picking of the commit which is there in the master branch. Okay, awesome. Awesome. But hey, I got a merge conflict. Yeah. When you see this message, first thing, do not panic, okay? Don't panic. Don't even try to delete anything. It's okay. And always remember, Git status is your friend. So whenever you see a merge conflict doing something, just type git status and see what it tells. It will give you some helpful commands and helpful steps you can do. So when I ran git status for this workflow, I have clearly seen, it clearly says that, hey, your readme.md file have a conflict. And what you can do is resolve those conflicts, add your file to the index area, and simply continue the cherry picking command. So it clearly gives you the instruction saying fix the conflicts and run git cherry pick -- continue. Super helpful. Okay, never forget this command. So, okay, fine, that's fine, but how do I resolve the conflict? Yes, using some of the tools with which you are comfortable is great, but it's still important to know how to read the commit conflict markers. So first thing is we need to understand what Git is trying to say. So anything between the first two markers, I wish this worked. Okay, yes, awesome. So anything between this and this two markers, these changes are actually what are present in your currently checked out branch. And anything between these two markers are the changes which are present in your master branch. For the cherry picking commit changes, these are this. So always remember, anything which goes in these two are the changes which are locally you are on. So these changes are the first two. This particular line is present on my React to meetup branch, and these changes are actually present in the commit which is present on the master branch. Okay. Once you know what change you want to, make sure you delete those weird markers and also the okay, yeah. Make sure you delete the all these extra markers and also the unnecessary change. Use your best knowledge and judgment when to have what you want to. Okay, awesome. Now I have resolved my conflict. I've continued with the cherry pick, and this is what my current workflow contains. Okay, so I have successfully cherry picked this particular C6 commit into my React to meetup commit. My head pointer is automatically moved to the latest commit. Awesome. So I have all these commits in my current working directory. Okay, one more thing which we need to remember is whenever you do run cherry pick command, it won't delete this old commit. So I don't want that to be on master branch. What can I do? First thing, I will switch back to the master branch. So if you remember, I was on the React to meetup branch. I'll switch back to the master branch because the commit which I want to delete is on master branch, C6. So I'll switch back to master. As you can see, the head is pointing to my master branch. And also note the parent commit for C6, the commit which I want to delete is C3. Okay. I run the reset command. Very helpful. You know, sometimes when you want to just undo your commits, you're embarrassed of the commit message you have done, just run git reset. So I run git reset -- hard head till 1. So what I'm saying is I'm telling git to move the head pointer up 1 commit backward, that is move to the parent commit of the commit which I want to delete. And yeah, that's it. You will not have the changes in your local working directory. So there are again a lot of arguments related to it, but I will not go further from here. Again, one thing you need to remember, whenever you delete this C6 commit, it is deleted from your branching. The pointer is like removed from it, but the commit will be still existing in your local directory. If you actually open the Git object folder, you will still see that hanging around there. So that's where the git gc command comes in handy. It's a garbage collector command, but git, just run it. It removes all the commits which are hanging around there, pointing to nothing. Okay, I'm running out of the time, but this is the last one. Okay, 2 minutes. Merging, yay, I want to talk about it. So I will not leave the stage without completing this. So so if you're a maintainer of any project, I feel you, okay? Merging is not easy. So let's assume that this is my current workflow, okay? I have these commits on my React to Meter branch, and that's my master branch. So now I want to merge the React to Meter branch into my master branch, okay? So how do I do it? I switch to the master branch because that's where I want to merge the changes into. So I switched back. The head is pointing to my master branch now. And I run git merge react to meetup. That's the branch which I want to merge the changes from. And again, I warn you, if there are any merge conflicts, it will tell you. And you know what to do if you see a merge conflict, right? I'm sure you're confident now. And what exactly Git does is Git creates a new snapshot, and it automatically creates a new commit pointing to both of these commits over here, the commit C6 and C7. And something which is special about C8 is it's known as merge commit. It has 2 parent commits, that's C7 and C6. And this, once the merge is successful, the head pointer is automatically moved to C8. And always remember, if you're done with a branch, please delete it. It will just make your Git log the branching workflow looks shitty. So please remember that. And the merge which I have just shown you is a 3-way merge. There's another type of a merge which I don't want to talk about right now. But yeah, that's about merging. As a final conclusion, Git is not as scary as you think. Like if you just sit on some Git workflow and spend some time to understand, branching and these all day-to-day commands we run, you will become a pro for sure. And some of the important resources, yes, the documentation, we are shit scared of it, but it's very useful if you actually understand some of the terms. It's very useful. And also the Git Pro book is amazing. Okay, just Google for Git Pro book. It's open source. It talks about different scenarios, merging, rebasing, all these different concepts. It's amazing. Give it a try. And hey, that's how you can tame the Git osaurus. Be confident in whatever command you run. You can definitely do it. And that's the end. Thank you.